All right, this is lesson 10, increasing and decreasing functions. Archimedes is one of the most well-known mathematicians in all of history. When asked by the king of Syracuse to determine if a crown was pure gold, Archimedes took the challenge. He discovered his answer while taking a bath. He realized that when he got into the tub, a certain amount of water was displaced. He could do that same with the crown. Excited, he screamed, "Eureka!" and took off to tell the king. We will control the level of water in the bathtub by turning on and off the tap, taking the plug in or out, and by having Archimedes get in and out of the tub. This will create a graph relating time and depth. So describe the changes in the graph. So what we're going to do is we are going to draw a graph and then vary what happens, okay? So I am going to draw the graph as we go here, and then here, 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 and here. So this is going to be 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So now it says describe the changes in the graph. So number 1, we turn on the tap. Okay. Number 2, we put the plug in. Number 3, we turn the water off. Number 4, Archimedes gets in the tub. Number 5, Archimedes stays in the tub. Number 6, Archimedes gets out. Seven, the water sits in the tub. And 8, we take the plug out. Okay. So what would be the fastest way to overflow the tub? Fix this. There we go. Well, the fastest way to overflow the tub would be Archimedes. In the tub. Plug the tub. And put the faucet on. And put the faucet on. Full power. Okay. Describe the conditions under which there should be no change in the level of water in the bathtub. The plug is in and the water is off. So now number 2 says, the graph below represents the total number of smartphones that are shipped to a retail store over the course of 50 days. Okay. So now we need to finish this graph so it goes over 50 days. Okay. So here we go. We do this. Now, if this were A, and this were B, and this were C, it says read through the scenarios and sketch a graph of the function that models the situation. Well, the production schedule was normal and the smartphones were shipped to the retail store at a constant rate. Well, that's a positive slope. And that's A. A defective electronics chip was found and the factory had to shut down, so no smartphones were shipped. That's a 0 slope. And that's why we have B or 2. And then for C, half of the factory workers went on strike and not enough smartphones were produced for normal shipments. Well, that's increasing, but at a less rate. So now, number 3 says the graph below shows the distance from Lucas's home as he walks his dog in his neighborhood. Describe the chance that the distance from his home over the change, in the distance from his home over time. Okay, well, Lucas is walking away from his home. He stops. To give the dog a treat. He continues down the road. Then turns to head back home. Next, not all real-world situations can be modeled by a linear function. There are times when a nonlinear function is needed to describe the relationship between 2 types of quantities. Compare the 2 scenarios. Alpha is running at a constant rate on a flat paved road. The graph below represents the total distance he covers with respect to time. Shannon is running on a rocky trail that is initially flat and then leads up a steep mountain. The graph below represents the total distance she covers with respect to time. Number 1, in your own words, describe what is happening as Elf is running during the following intervals of time. So from 0 to 15 minutes, okay, Elf runs 2 miles in 15 minutes. Between 15 to 30 minutes, okay, he runs another 2 miles in 15 minutes. Total, 4 miles. From 30 to 45 minutes, he runs another 2 miles in 15 minutes for a total of 6 miles. And then for the last, he runs another 2 miles in 15 minutes. Total, 8 miles. So in other words, this is all a constant rate. But now for Shannon, from 0 to 15 minutes, she runs about 1.5 miles in 15 minutes. From 15 to 30, she runs about 0.06 miles, or sorry, 0.6 miles. Total, 2.1 miles. In the next 15 minutes, she runs about 0.5 miles in 15 minutes. Total, 2.6 miles. And last, about 0.4 miles in 15 minutes. Total, 3 miles. So she's running at an increasing rate. Sorry. So her slope is increasing. So she is increasing. This right here. I can't write this right. So it's actually increasing. Okay. but at a decreasing rate. Okay. So now for example 2, we've got the rate of change of a function can provide useful information about the relationship between two quantities. A linear function has a constant rate of change. A nonlinear function has a variable rate of change. Okay, so here, notice that this linear function is increasing at a constant rate. This is increasing, but at a variable rate. Here, we have it decreasing at a constant rate. This is decreasing at a variable rate. This linear function has a constant rate. This nonlinear function has a variable rate. Okay? So next we have, for practice, we have Nika, who took her laptop to school and drained the battery while typing a research paper. When she returned home, Nika connected her laptop to a power source, and the battery recharged at a constant rate. Sketch a graph that represents the battery charge with respect to time. Okay. Need to find my ruler. Sorry, guys. So I would say with respect to time, okay, the battery would charge depending on how long it takes for that battery to charge. Okay. Okay, I would just say it would do that. And is the function represented by the graph linear or nonlinear? I would say it's linear because the battery is recharging. At a constant rate. Is the function represented by the graph increasing or decreasing? It is increasing. The battery is recharging. Okay. So next, excuse me. Lamar and his sister are riding a Ferris wheel at the state fair. Using their watches, they find that it takes 8 seconds for the Ferris wheel to make a complete revolution. The graph below represents Lamar and his sister's distance above the ground with respect to time. Is the function represented by the graph linear or nonlinear? Well, it's nonlinear. It says, where is the function increasing? Well, it is increasing at 0 through 4 seconds. 8 to 12. Oh, let me fix the light. (16 to 20). 24 to 28. And 32 to 36. Okay. And it says, what does this mean within the context of the problem? That means that Lamar and his sister are rising in the air. It says, where's the function decreasing? It's decreasing at 4 to 8, 12 to 16, 20 to 24, 28 to 32, and 36 to 40 seconds. And this means that Lamar and his sister are traveling backwards back towards the ground. How high above the ground is the platform for passengers to get onto the Ferris wheel? And explain your reasoning. Okay. All right, the lowest point as you can see is right here. Okay. Which is 5 feet. And that is where the platform is. Where people get on. Based on the graph, how many revolutions does the Ferris wheel complete during 40 seconds? The 40-second time interval, and explain your reasoning. Well, if we count them, be 1, 2, 3, 4, and 5. So 5 revolutions. Because the lowest point is the beginning of a new revolution. What is the diameter of the Ferris wheel? The diameter of the Ferris wheel is 40 feet. The lowest point is the base of the Ferris wheel. And the highest point is the top. So the difference is the diameter. And that ends our lesson for today.